DynaFlex Performance is Turbine Technology Services platform for maximizing gas turbine output and efficiency, optimizing DLN combustor dynamics and emissions, and enhancing operational flexibility. Here are some of the system's highlights. Markets and energy demand are changing rapidly, focusing companies to rethink how they operate their power generation assets. Fleet flexibility is the ability of the generation fleet to change its output rapidly, start and stop with short notice, and achieve a low minimum turndown level. For many operators, the goal is to be classified as spinning reserve, where online reserve capacity is synchronized to the grid system and ready to meet electric demand within 10 minutes of a dispatch instruction by the ISO. For F units, faster starts can be achieved by implementing some or all of the following changes, whether it's modifying fuel systems to obtain a purge credit capability or pre-connecting load-commutated inverter. Gas turbine operators may receive payments based on their maximum generation capacity, or they may need to hold a certain amount of generation in reserve as a percentage of their maximum capacity. For these reasons, adding peak firing capability to both simple and combined cycle units can bring economic benefits, even if the peak fire capability is not utilized in normal operation. Implementation of peak firing requires control system logic modifications, HMI modifications, and combustion tuning to achieve the optimal balance of NOx emissions and dynamics. Lean blowout and regulatory NOx excursions are common operational problems on DLN 2.6 systems that have been improperly tuned. Our team understands the impact of ambient temperature variation on inducing these problems and establishes tuning criteria to eliminate their future occurrence. Sometimes a turbine comes out of a scheduled outage with significantly increased NOx above regulatory limits. TTS will analyze pre- and post-outage turbine performance data to diagnose the cause of the problem and provide short- and long-term solutions to maintain operation within compliance. Combustion tuning is required for DLN combustion systems during initial unit startup and periodically any time after combustion or hot gas path hardware is changed. DLN tuning ensures that the DLN combustion system operates within its regulatory emissions limits, while maximizing combustion dynamic pressure levels and providing sufficient lean blowout margin over the low NOx operating range. Our combustion engineers can travel to your site or connect remotely to carry out this tuning exercise. The combustion engineer uses site CEMS emissions data and CDMS combustion dynamics data as necessary to assess the condition of the system and to make changes to optimize emissions and combustion dynamics to minimize combustion hardware stress levels. Dry low NOx, or DLN combustors, operate at a very lean fuel-to-air ratios to meet single-digit NOx emissions regulations. Regular tuning of these systems is required to ensure compliance with emission regulations and long-term component integrity. TTS's CMS 1000 combustor dynamic monitoring system is specifically engineered for measuring dynamic pressure pulsations in gas turbine DLN applications. Hardware configuration and setup are simple, and the software is user-friendly, providing data in formats that DLN tuners and operators need for easily DLN optimization. Where customers do not have a permanently installed CDMS system, TTS can rent a portable system for use during the tuning process or can build a system for sale to customers. Gas turbine performance is driven by dynamic flexibility. DynaFlex.